Point 2, graphs of equations in two variables, intercepts, symmetry. So let's first look at intercepts. So suppose I have some curve, and let's do this relative to some coordinate system, say this coordinate system. The graph of is just a set of ordered pairs in the relation. The x-intercept are the places where this curve intersects the x-axis. The y-intercepts are the places where this curve intersects the y-axis. The x-intercept can be found by setting y equal to 0. So if you notice here, these intercepts occur when at the x-axis when y is equal to 0. So to find the x-intercept, you set y to find the y-intercept. Well, you notice that the y-intercept occurs when x is 0. So you would set x to 0 and you would solve for y. Let me do some examples. On page 18, let me do problems 19-30. Find the intercepts and graph each equation by plotting points. Be sure to label the intercepts. So problem number 26, y equals negative x squared plus 1. So I want to find the intercepts. So let's first find the x-intercepts. Recall, to find the x-intercepts, you set y to 0 and you solve for x. I can factor this directly, or I can multiply by -1 and factor it. I'll just factor it this way. So this factors as a negative x plus 1 times x plus 1. I have here a negative x squared minus x plus x cancels, plus 1. So by the fact that the integers are an integral domain, I can, since the product is 0, then one of the factors must be 0. So by the zero factor property, negative x plus 1 is equal to 0, or add x to both sides of your equation. So x is equal to 1. Subtract x from both sides of my equation. So x equals -1. And so I have that the x-intercepts are at 1, 0, and at -1, 0. Okay. Let's determine my y-intercepts. In general, if you have a function, you'll only have one y-intercept, at most one y. If it's not a function, then you can have more than one y-intercept. So recall, to find the y-intercept, you just set x equal to 0 and solve for y. Well, -0 squared is 0, plus 1 is just 1. And so my y-intercept is at 0, 1. So those are my intercepts. Given those 3 points, we should have enough points to be able to plot a parabola. Okay, trying to draw a straight line if I can. Don't know if I can do it, but I'll try as best I can to draw it. Okay, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 9, 10. 1, 2, 3, 9. Okay, so I have a y-intercept at 1 and x-intercepts at plus and minus 1. So it should look something like the following. So these are at 1, minus 1, 1. And so this is the graph of y equals negative x squared plus 1. Any questions about that? Okay. Let me talk about symmetry. Okay, so first, symmetry with respect to the x-axis. And so a graph is said to be symmetric with respect to the x-axis if for every point xy on the graph, the point x minus y is also on the graph. So if you say this is x and y axis, if you have some curve here, it's symmetric about the x-axis if for every x here, you have a y and a negative y. It's the same distance from the x-axis. Symmetric with respect to the y-axis. A graph is said to be symmetric with respect to the y-axis if for every oh, that's what that symbol means. Oh, I see, I didn't use it up here. If for every point xy on the graph, the point minus xy is also on the graph. So this is symmetric with respect to the y-axis if, let's say like this. If if you have here, say a y value, then there's an x and a corresponding negative x on the other side. You just flipped it on the other side. And so the distance from this point here is x, and from that point is also x. So it's symmetric about the y-axis. It looks the same on one side of the y-axis as compared to the other side of the y-axis. Symmetric about the origin. A graph is said to be symmetric with respect to the origin if for every xy on the graph, negative x, negative y is also on the graph. So if I take some point, say it's symmetric about the x-axis, and so it goes here, and with respect to the y-axis. So you do sort of two sort of flips. If you take this curve, flip it about the x-axis, and then flip it about the y-axis, it still looks the same after you've done those two operations. So this distance here is the same to the origin, the same as that distance there to the origin. And so you've taken this point and brought it over here on the antipodal side of the origin, on the opposite side of the origin. Okay. Problem 32. in problems 31 through 40, plot each point, then plot the point that is symmetric to it with respect to A, the x-axis, B, the y-axis, C, the origin. Okay, so let me do that. So it's a 0.53. Okay. It'll be a little slow here. Okay, so I have here 5 minus 3, 3 minus 5. Okay. Let me just complete the rest of my tick marks, just so it looks nice. They aren't going to be really necessary, but okay, so I'm here at the 0.53. Now I want to first reflect about the x-axis. So actually, maybe I'll make this a red point. So I'm going to flip here. So this is going to be respect to the x-axis. Okay. So it's going to flip over. It's going to have the same x coordinate, but the y coordinate will have an opposite sign. So this will be the 0.5, negative 3. So this distance here to the x-axis is the same as this distance here to the x-axis. Next, oh, I don't care, maybe purplish. How about that, purplish? So let's flip here and let's do this with respect to the y-axis. So we're going to take this point and flip it on the other side. So you will have the same distance from the point to the y-axis. So this will have coordinates negative 5, 3. Okay. Lastly, I want to do this respect to the origin. So I'm going to take it so it's the same distance here from the origin to this point, 5, 3. And so maybe I'll do it as green. So this will be at negative 5, negative 3. So this distance here is the same as this distance. That it is really the same as doing these two previous operations. You flip it over to the other side of the x-axis, then flip it over to the other side of the y-axis, or vice versa. Flip over to the other side of the y-axis, then other side of x-axis, and you get it. That is, you've made it the antipodal point from the origin. Okay. Any questions about that? Any questions about that? Oh. Sure, that's fine. Oh, here it is. Aha. I just saw this. So the graph we just did, is it symmetric with respect to the y-axis? Let me look. It certainly is symmetric with respect to the y-axis. So if you look here, it actually is symmetric with respect to the y-axis, because if I replace x by negative x, well, a negative x squared is just x squared. So I would still get that it satisfies the same equation. So therefore, that means that this is symmetric with respect to the y-axis. axis. Since formation, maybe I'll do it in red. If we replace x by negative x, the negatives cancel, so you just get a minus x squared plus 1. So therefore, that means it's symmetric. Oh, sorry about that. That it's symmetric. With respect to the y-axis. A little bit of a lag here with respect to the y-axis. So the answer is yes, it is symmetric with respect to the y-axis. Okay. Boy, that would, this is so slow. And x-axis. This is not symmetric with respect to x-axis. So in this case, it's only symmetric with respect to the y-axis, not the x-axis. Okay. I was there. Aha. Okay. Any other questions about anything before I go on? Okay. In problems 41 through 52, the graph of an equation is given. A, find the intercepts. B, indicate whether the graph is symmetric with respect to the x-axis and x-axis, y-axis, origin, or none of these. So let me do that. So this is my graph here. Okay, so I want to find the intercepts. I'm going to, obviously this is done visually. This is sort of a guess as far as intercepts, symmetry, visual inspection. I'm going to be doing this. So first, the x-intercepts. So the question is, well, does this intersect the x-axis? The answer is no. So there are no x-intercepts. So no x-intercepts. Okay, next, y-intercepts. So again, let's visually inspect this and see if we have any y-intercepts. Well, yes, it does intersect. It intersects here, and it looks like it's intersecting at 1. So I'll make the assumption that it intersects at 0, 1. So by visual inspection, we have that it intersects here at 0, 1. Let me do another little. Okay, no questions so far. Let me, lastly, let's look here. Does this look symmetric with respect to the x-axis? Certainly not. There's nothing down here. So it's certainly not symmetric with respect to the x-axis because there's something above the x-axis, but nothing below the x-axis. So Not symmetric there. Let's see, is it symmetric about the y-axis? Does it look the same over here as it does over here? Well, no, you have it up here, but it's not up over here. So that's a no. Is it symmetric about the origin? Meaning if you flip about the y-axis and the x-axis, does it look the same? Well, certainly not, because that would make points up here go to points down here, and there's no points down here. So no, that's certainly a no. So it's neither. So symmetry. So it's not symmetric with respect to the x-axis. Oh, WRT means with respect to, in case W, that's a with respect to. It's not symmetric with respect to the x-axis, nor, and well, I'll just say not symmetric with respect to the y-axis, not symmetric with respect to the origin. So it's neither, none of the above. So none of the symmetries that we have discussed. Actually, they don't have any symmetries. Okay. Let me do problem number 46. So in problem 46, it's asking the same questions. So intercepts. So first, let's look at the x-intercepts. Here we have a whole bunch. So the x-intercepts are, well, at plus or minus 2. And so -2, 0, and 2, 0. Let's look for the y-intercepts. Well, in this case, we have, well, 2 at 0, -2, and at 0, 2. Okay. Next, let's look for symmetries. Here, it seems to be symmetric about everything. So this side looks the same as this side. And so this is symmetric about the y-axis. It is. Looks the same here as it does here. So this is symmetric about the x-axis. And so if you take this point, well, its antipodal point is also on the graph. And so every antipodal point corresponds to, well, a point on the graph. And so it's also symmetric with respect to the origin. So a circle is very symmetric. So in this case, it's symmetric about everything that we can think about, everything that we talked about. Okay. Any questions about that? Okay. Oops. Problem 64. In problems 57 through 72, list the intercepts and test for symmetry. Okay. So let's first find the intercepts. So let's look for the x-intercepts first. So to find the x-intercepts, we set y to 0 and solve for x. So 4x squared is equal to 4. So x squared is equal to 1. Okay, so x squared is equal to 1. So x is equal to plus or minus 1. Okay. Someone has a question. Oh, okay. Any other question? Any question? You'll have to type it in because I can't hear, unfortunately. Ah, here it is. Okay, come on. Is there a lunch break? No, there's no lunch break. No questions. Okay. Oops. Oh, well, it doesn't matter. Okay, so let's find the y-intercepts. So the y-intercepts are found by setting x equal to 0 and solving for y. So 0 plus y squared is y squared. So y squared equals 4. So y is equal to plus or minus 2. And so the intercepts are at 0, -2, and at 0, 2. Okay, so now let's look for symmetry. Let's look for symmetry. Oh no, let's say about the x-axis. So to test if something is symmetric about the x-axis, you would just replace y by -y and see if the equation is still the same equation. And so I have 4x squared plus y squared equals 4. Let's square this, so I get 4x squared plus y squared equals 4. And so yes, it's the same equation. So yes, it is symmetric about the x-axis. Okay. Let's see if it's symmetric about the y-axis. So to test if it's symmetric about the y-axis, I replace x by negative x and see if the equation is still valid. And so I'll replace x here by negative x. And let's see if this equation still holds. Well, negative x squared is just x squared. And so, yes, this is the same equation. And so, yes, this equation here is invariant under the transformation, replacing x by negative x. So yes, it's symmetric about the y-axis. So symmetric about the y-axis. Lastly, let's see if it's symmetric about the origin. And well, since it was symmetric about both of them, it's going to be symmetric about the origin. And so let's check. So symmetry. So is it symmetric about the origin? So in this case, I'm going to replace xy by negative x, negative y. And let's see if the relation is invariant under this. So I have 4 x squared plus y squared equals 4. So let's see if this is still valid. So the negative x squared gives me an x squared. The negative y squared gives me a y squared. And this is indeed equal to 4. So yes, this is symmetric about the origin. So just like in the previous, the x-axis, the y-axis, and the origin, this is actually an ellipse. So if you actually looked at the graph of this function that they gave you, well, not actually not a function, this relation that they gave you, the graph of it would look like an ellipse. So it has a lot of symmetries. Okay, let's do problem number 82. Yes. Any questions? Okay, let's see if I can do this. No questions. Okay. Problem number 82. If the graph of an equation is symmetric, respect to the x-axis, and 2 is a y-intercept, name the other y-intercept. So since it's symmetric, with respect to the x-axis, that means that it's invariant under this transformation where I replace y by negative y. And I have that 2 is a y-intercept. So I have a y-intercept of 2. Actually, we're a little sloppy. We don't mean that that's the y-intercept. We mean that that is the y-coordinate of the y-intercept. So the y-coordinate of the y-intercept is 0, 2. Okay. So since from this first, and maybe I should, here, let me actually move this down for 1 second. So this really said that if I had xy as a point in the relation, then x negative y is also a point in the satisfies the relation. So if 0, 2 is in the relation, then by this, I have that at 0. So therefore, I've shown that the y-intercept, that another y-intercept is 0, negative 2. And so I've found the other y-intercept. Any questions about that? Oops. Okay. Oh, no. Go ahead. Yes. Someone has something about the online text. The online text should be the same as the book that I'm using. So any page that I'm referring to should be the same as the PDF of a book having the same version as the version that I'm doing. If you're using a different version of the book, then the page numbers will be similar and the problem numbers will be similar. Sometimes there may be, that it's 2 or 3 pages away and maybe 2 or 3 problems away, but they should be very similar and easy to translate in between the two. Okay. Okay. Any questions on section 1.2? Because otherwise that finishes off section 1.2.